Hi there. Today I am going to discuss 5 hard entry-level questions of momentum and Newton's laws of motion. These are kind of hard, but kind of very really entry-level. So if you have any doubt of how to do some hard questions, it's the best video to see this one.
To start, I'm just going to introduce you a very simple question like the track accelerating along a slopy path like in the animation given here. It starts with the 0 and reach to some velocity of v with an acceleration of 8. Let me read it for you. A truck starts from a restaurant roll downhill with a constant acceleration, travels a distance of 400 meters in 20 seconds. Find its acceleration, find the force acting on it. The mass is 7 metric ton. Hint is just 1 metric ton is equals to 1000 kilogram. So you just need to write down the initial results like following, because it will be easy for you to understand. This distance travel is 400 meters and the time taken is some 20 seconds. Now we have to apply it into the motion equations that of s equals ud plus half ad square. So let me just analyze the results now. The distance is 400 meters according to the diagram as I draw it. You can see that the time is equals to 20 seconds as it moved down the track, and the initial velocity is 0 and the final velocity is something we really don't want to do that in the calculation, so neglect that. So now let's apply to the results onto this one. Now the distance is 400 meters and now just application of to the equation u equals to 0, so I can cut it off the complete term of ut out of the equation. Then the equation becomes s equals to half ad square only. The distance is 400 meters and now I'm going to apply it into the half a to the square. So now the result is going to be 400 and 400 cut off. The acceleration is 2 ms minus 2. As a 1 metric ton is equals to 1 kilogram, for the 7 metric tons the mass is going to be 700 kilograms. Mass of the truck is just 7000 kilogram, and from the Newton's second law of motion, F is equals to ma. So the truck traveling downwards the slope, so the F equals to ma. 7000 times 2 is 14,000 Newton. So you can find out the acceleration to ms minus 2 and the force as 14,000 Newton. Really simple.
You learned something from the previous one. Now this one I'm just about to talk about something like what? A train and the application force of the supporting force from the engine and the opposite forces, that resistive forces, and the resultant force, and how the acceleration appears and how the force affecting each compartment differently and safely. And it's kind of like a little tricky question. I hope you to enjoy the question. Okay,
an engine of 8,000 kg pulls a train of 5 wagons each of 2,000 kg and the horizontal track. If the engine exerts 40,000 Newton and the force of 5,000 Newton, then calculate the acceleration of the force and acceleration of the train and the force between wagon 1 or to wagon 2. Now let's apply to the Newton's second law of motion, and you can see according to the acceleration of the animation. So the force exerted is going to be like 40,000 Newton, and this is a really tricky question. You have to find out the force between the track 1 and the track 2. So the engine force. Now I'm going to apply these results into the free body diagram as following. So you can see the forward force is the 40,000 and the backward resistive force is 5,000. The actual driving force, we can find it like that way. The resultant force 40,000 minus 5,000, that's going to be some 35,000 Newton. That is the actual drag force of the driving force. Because of the, now we can simplify the force into F equals ma. Again in a free body diagram, the force is at the left hand side and the acceleration also in the left hand side. You calculate something like this. Always analyze the results and draw as possible as the free body diagrams. Now see the results. Now the train, mass of the train, that can be taken as capital M. Though the mass of the wagon is going to be, total wagon is simple M. The mass of a wagon is M double dash, and you have to multiply that with the number of wagons, that are 5. So you can find easily the mass of total wagon is going to be 10,000 kilograms, and I can get the total mass of the stuff as capital M plus M dash is for the engine, M is for the total mass of the wagons together. So overall mass is 18,000 kilograms. So applying to the F equals to ma, acceleration and the capital M over and acceleration, and 35,000 over 18,000 is going to be 9.44. Now I approximated it to some 2 ms minus 2, because this approximation is really important to do the calculation for the forward, because it's really convenient. Now I'm going to find out the force between the next one. Now it's kind of you have to separate like M dash and M. That means the engine and the train like this one, so you have to separate it using that green line like this as I mentioned here. And your force is going to be the tension between the first compartment and the second compartment. So the rest of the compartments there are 4 compartments, so the mass of the 4 compartments is for 8,000 kilograms, because one compartment is some 2,000 kilograms. So you get the final mass as 8,000 kilogram, and you just need to apply the Newton's second law for the rest of the wagons with the acceleration of 2 ms minus 2. So the rest of the wagons you have to drag it with force of 16,000 Newton. That is the force. You just need to drag the train along, so rest of the stuff along the path with the acceleration of 2 ms minus 2. Simple. Because the acceleration is the one you can have to apply to Newton's second law of motion, F equals to mh. Then you can find out the total force you need to drag the rest of the 4 wagons. Nothing else. It's really simple. It's not complicated rocket science.
Okay, I think you learned previous 2 questions. Now it's time to learn about something collision of 2 objects. Okay, it can be something like 2 bullets colliding on each other, 2 collisions, and how the momentum behave on this type of motion collision.
Let me read the question for you. And 2 objects, each of mass 1.5 kilogram, are moving in the same straight line but in opposite directions. The velocity of each object is 2.5 ms minus 1. Before the collision, during that it sticks together, what will the velocity of the combined object after the collision? Now you have to think 2 things. One, the 2 independent objects moving towards each other with same velocity with the opposite directions. And after that the collision, they're just going to stick together. The first one is moving with 2 ms minus 1 towards the right hand side, and the second one towards the left hand side, but equal magnitude and opposite directions. After the collision, both going to stick together and move somewhere, like it can be the direction right hand side with the velocity of v, to left hand side with the velocity of v. We don't know after collision what's going to happen. Now we have to analyze the result. Mass of one object is 1.5, second object is also 1.5, and the velocity of the first object is 2.5 ms minus 1. Second object is also 2.5 ms minus 1 with the minus sign. The minus sign indicates the motion is towards the opposite direction. Come to think of the certain vector x, if you move from x to y, so this direction is positive. If you start to move from the y to x, the direction is going to be negative. This is basic simple vector knowledge. Now let's apply the results to the stuff. Now after the collision, 2 objects stick together. The total mass of the objects become m1 plus m2, and the objects to the combined velocity of v. Really simple. Now m1 v1 and m2 v2 are the relations of what of v initial before the contact. Now after the collision, the stuff going to be v final. So the m1 plus m2 times v, the combined results, that combined result according to the law of conservation of momentum, initial momentum, that should be equal to the final momentum after the final momentum. So this one, m1 v1 plus times m2 v2 is going to be equal to the final momentum of m1 plus m2 bracket v. So this is simply v initial should be equal to p final according to law of conservation of momentum, nothing else. Now let's apply the results to the calculations. Now 1.5 times 2.5 plus 1.5 times minus 2.5 because of the opposite direction, and m1 plus m2 times v is going to be the result, and 3.75 minus 3.75 is going to be 3v. V is going to be 0. That means the momentum is cancelled out by each other. It's really simple to understand.
It's about something little even trickier. A bullet penetrating into a log of wood and just stop over there after some deceleration. And how to find out the force acceleration and the acceleration, how to use the laws of certain, and how to use the linear motion equations, and everything is explained there in graphical representations and many other things. And enjoy the video. Very next question is kind of really trickier because most of the students find this one as a really tricky for them, and let's find out. Let me read it for you. A bullet of mass 10 gram is traveling horizontally with a velocity of 150, strikes a stationary wooden block and comes to rest within 0.03 seconds. Remember that. And calculate the distance penetration of the object to block, and also calculate the magnitude of the force exerted by the wooden block of the bullet. Let me show you with the simple animation. The 10 gram mass is moving towards with the velocity of 150 ms minus 1 and strike the block. After the strike, the wooden block, then the bullet is going to penetrate through the staff. You can see that in the animation now with the high velocity comes to rest gradually with a deceleration of A, and according to the resistive force of Fr, and it has traveled some distance of S into the block. Really simple to understand in this manner, because the always resistive force is opposite, that the given that the velocity is 150 at the beginning, you have to analyze the results like this way, and the final velocity is equal to 0 and the time taken is like 0.03 second. Now we have to convert this into this complicated diagram into very simple way without complication. Now you have to understand this is simple, what? Linear motion, nothing else other than what? Simple linear motion. Let me convert it. Now to draw a straight line, and the distance you don't know, and the initial velocity is 150 ms minus 1, and the same mass, and the final velocity is going to be 0, and the acceleration is always going to be the opposite one. So the resistive force is always applying against it. T is equal to 0 at the beginning, and at the end it's 0.03 seconds. That's how you have to apply the results. And the resistive force and decelerate makes it into some distance, depenetrate into that. So you have to choose the ideal equation. My equation is going to be V equals U plus 80 for this one. Now the V equals going to be 0 and U equal 150, and the A I don't know, and the time taken is 0.03 seconds. Let me just show you the way how to get it. The acceleration is equals to 150 divided by 0.03, that's going to be negative 5000 Newton, ms minus 2. Negative sign indicates that this is going to be rapidly decreasing the speed, nothing else, this decreasing. Now let's move to the analysis. Now I have to use the second times of the motion of equations like v square plus u square plus 2s. Final velocity is 0 and initial velocity we know, and the 2 is constant in the equation, and finally I've found the acceleration. Now I have to apply it into there. So 150 square is 22,500, and 2 times 5,000, then you have to divide it and get the acceleration. So distance as 2.25 meters. It's a very big distance in come to think of a wooden block, okay? And the Newton's law of motion that now can apply because we know the acceleration equals to ma, mass already known. So the mass of the bullet is 10 grams. You have to convert it into SI units to get 0.01 kilogram. Why? Because we always need to apply the SI units, nothing else, no other units for most of the calculations. Acceleration is equals to 5000 Newton, and 0.01 times 50, it's going to be the 50 Newton. The force is just 50 Newton. The final one is really consolation one. It's not very big deal, and it's just about to deal with some change of momentum from lower states to higher states, and how to find out the force, relationship of force and momentum, like of the Newton's second law of motion. Just let me read the question for you. An object of mass 100 kg is accelerated uniformly of 5 ms minus 1 and 2 height ms minus 1 within 6 seconds. To calculate the initial momentum and final momentum of the object, and also the magnitude of force exerted by the object. This question is really different one, because we are just about to find out a force using the change of momentum, and we have to write down the reasons like u equals 5 ms minus 1, v equals 8 ms minus 1, m is going to be 100 kilogram, and the time is 6 seconds. So let's just analyze this one. Before doing that, we have to get some change of momentum. In the getting the change of momentum, see, start from 5 ms minus 1, and it reached to higher velocity of 8 ms minus 1, and the initial momentum, that is going to be mu, that means 100 times 5, 500 kg ms minus 1, 100 times 8, 8 times minus 1 for the
final momentum. So that according to the equation, F is equals to mu minus mv minus mu over t. That means the second law is the rate of change of momentum. So the delta p over delta f is equals to delta p over delta t is going to be equals to force. That's according to the Newton's second law. So let's apply the results. Mu is the final momentum and mu is the initial momentum and the t is the 6 seconds. Now we just can apply the results like mu minus mu to our t, then 8,100 over 5,500 over 6, that means 300 over 6, that's 50 Newton. The result is 50 Newton, really simple.
Okay, I think you enjoyed the video, you learned something from it, and to get my next updates, and like and comment and subscribe and hit the bell icon to get notified, and hope you enjoy the video. Okay, God bless you, bye.